Thank you for the opportunity to explain our recently funded project titled Catalytic Upgrading of Carbohydrate in Waste Streams to Hydrocarbons. I'm Seongyu Park, faculty member at the Department of Forest Biomaterials, North Carolina State University. So the overview of this funding program. Our project is funded by U.S. Department of Energy, Office of Energy Efficiency and Renewable Energy. And the funding opportunity announcement, which they call it FOA, was Bioenergy Engineering for Product Synthesis, or they call it BIPS. And we submit a proposal to topic area 4, that is focusing on wet organic waste stream. So this program's objectives are very clear here. They want to make biofuels and bioproducts from wet organic waste, so that can support the bioeconomy. And wet organic waste from industry, commercial, and residential often present a disposal problem, and then also they end up in environmental issue as well. So in this FOA, they ask to develop the systems at a relevant scale, which is up to 50 liter of reactor volume, and also demonstrate the potential to reduce 25% of disposal cost. So our project recently funded is the titled Catalytic Upgrading of Carbohydrates in Waste Streams to Hydrocarbons. And our objective is to develop a technology for converting the hydrocarbon in paper sludge, pulp and paper sludge, into a carbohydrate biofuel. And the biofuel we are targeting is jet or diesel fuel compatible hydrocarbon. So this project is 3-year project, and then the funding amount is little more than $3 million. And NC State is a lead institute, and then DOE, National Renewable Energy Laboratory, is the subcontract working together with us. So if you look at the pulp and paper industry, and this is the picture from one of the pulp and paper industry in United States, and this industry, this facility handles about 2,000 ton of wood chips, dry basis wood chip of 2,000 per day. So this is a massive operation. They do pulping, they do paper making, they do chemical recycles, and all kind of massive operation using 2,000 ton of biomass every day. And during that, they have liquid waste and solid waste. As you see in this table, the solid waste in this pulp and paper industry, we call it sludge. And then entire US, the total amount of sludge in the yellow box, as you see that, is about 7 million dry ton per year. And then the total production is about 74 million ton of total pulp and paper and tissue production. So you can say that about 10% of the material comes out as a sludge. So this is not a small amount. And if we use this material into high value products, that will help environment a lot. This pulp and paper sludge is currently utilized as a land filling application, or digested in lagoon, or maybe some kind of land application, and also in many places it ends up in incineration to remove as a CO2. So there are actually that much beneficial utilization of this sludge. So what we want to do is we want to take this sludge and make into some value-added products. Why? If you look at this sludge composition, and then we can find out a lot of carbohydrate in it. So this is a table that we analyzed 3 different meals around NC State, and then we found that the amount of carbohydrate, which is the sum of glucan, xylan, and mannan in this table, is around 33% to about 60%. So 30 to 60% of the carbohydrate is in the sludge material that we can use to make it into valuable products. But at the same time, the challenging is the ash. This sludge contains very high content of ash, from 26% to even 55%. So this ash material is cause some problem during the conversion process. So we need to remove this ash first before we utilize this carbohydrate conversion. So this is our proposal. This is our proposed technology. So first, we will take this sludge and then we will remove the ash. So the first step is we will develop this ash removal process, and then this ash removed sludge, mostly carbohydrate, we do enzymatic hydrolysis, make it into sugar. And that point, now we have a glucose. And then we have a catalytic conversion to make into dehydration products. Here specifically, we are making HMF. And then this is the chemical structure. And then we have a aldol condensation so that we add ketone, and this ketone is condensed with this HMF. And then if we have another HMF, then it will make this another condensation like this. And then once we have this, we can do hydrodeoxygenation, which we remove the oxygen to make into hydrocarbon. So as you see this, our target is about C16 here. And then if we use xylose, then it will make about C12, C14 to C16 carbohydrate, which is comparable as a jet fuel and also diesel fuel. So our work plan is like this, as I explained. And then at the end, we will do very rigorous techno-economic analysis and life cycle assessment to demonstrate the benefit of our technology. Also, we will deliver these 2 factors here, and then we will show 25% reduction in disposal cost. And then during the research, we will demonstrate and produce the hydrocarbon products at least 1 liter scale, so that we can do some fuel tests to make sure this is good for diesel and jet range. The last slide is our technology impact. As I explained, we have over 7 million dry ton of paper sludge in United States, and then assuming some tipping fee, and that translates into $300 million per year of this sludge processing cost. But we can take this sludge and make it into hydrocarbon biofuel, so that we can make about 250 million gallons of hydrocarbon biofuels. And at the same time, we can reduce the disposal cost over 25%. And also, our technology can be applied to other organic waste materials, maybe something like food waste material, or maybe some animal waste material. As long as they have some carbohydrate in the material, then our technology can be applied. So our project is going to be started very soon for next 3 years, and then I will be happy to answer any questions if you have. Please contact us at this email, and then I will be happy to get back to you anytime. Thank you.